The hidden depths of space harbor worlds that will astonish your imagination. In the boundless universe, among stars and nebulae, there exist planets with conditions and features that could not be imagined even in the wildest fantasies. These worlds challenge our notions of what is possible in nature, and studying them could transform our understanding of the very essence of the universe. Some of these planets have characteristics that make us question our ability to perceive. Their extreme climatic conditions, unusual chemical compositions, and mysterious geological processes open doors to the unknown, sometimes too exotic for scientific theories. Imagine worlds where clouds of liquid metal merge with acid rains, or planets whose oceans are something more than just water. What are these incredible worlds that can challenge our perception of reality? And what can they tell us about the limits of the possible and impossible in the boundless expanses of space? If this tale of ancient mysteries and hidden forces has sparked your imagination, don't stop here. Like this video to share your excitement and subscribe to our channel for more stories that uncover the wonders and enigmas of our world. Together, let's explore the secrets that time has tried to keep from us. Your support helps us bring these fascinating stories to light. The discovery of exoplanets has always intrigued the scientific community, but the finding of the rare planet Kepler-16b was a real sensation. This unusual planet orbits two stars simultaneously, which is itself a rare phenomenon in astronomy. Kepler-16b is located about 245 light-years from Earth, and, like Tatooine, the home planet of Luke Skywalker from the Star Wars universe, it would have two sunsets if you could stand on its surface. Previously, Kepler-16b was discovered exclusively using the Kepler Space Telescope, which employed the transit method. But recently, a team of scientists led by the University of Birmingham managed to observe it using a ground-based telescope. This achievement was published in Science Daily, sparking a new wave of interest in this object. Kepler-16b was first discovered 10 years ago, when the Kepler Space Telescope first detected its transit across the stars. This technique involves observing a dip in a star's brightness when a planet passes in front of it, allowing astronomers to determine its size, distance from the star, and even atmospheric composition. The discovery was surprising because scientists had previously believed that planets in such systems, if they existed, would need to be located at a significant distance from their stars to maintain a stable orbit. Kepler-16b, on the other hand, surprised researchers with its orbit. According to Sarah Seeger, a planetary expert from the Massachusetts Institute of Technology, MIT, it was previously thought that a planet in a binary system should be located at least 7 times farther than the distance between the stars to avoid strong gravitational effects. However, Kepler-16b's orbit is only half that distance, challenging established notions about the formation and evolution of planets in such systems. Kepler-16b is also unique in its physical characteristics. The temperature on its surface ranges from 70 degrees C to 100 degrees C, making it extremely cold and inhospitable for life as we know it. A year on this planet, that is a full orbit around both stars, lasts 229 Earth days. Despite these extreme conditions, the planet remains a subject of intense scientific interest, as its existence helps to reconsider theories about planet formation and their stability in binary systems. The discovery of Kepler-16b marks an important milestone in the study of exoplanets in unusual conditions. It has confirmed that our universe is much more diverse than we might have imagined, and that the laws of physics may operate differently in various parts of space. The exoplanet HD 189733b, located just 64 light-years from Earth, is one of the closest hot Jupiters to our solar system. Discovered in 2005, it has become a benchmark in the study of exoplanet atmospheres due to its unique characteristics and proximity. The planet has drawn scientists' attention not only because of its closeness, but also due to the unusual conditions prevailing there. HD 189733b orbits its star at a distance 13 times smaller than the distance from Mercury to the Sun. This results in a year on the planet lasting only 2 Earth days. Due to its proximity to the star, the surface temperature of the exoplanet reaches an incredible 900 degrees Celsius. But the most astonishing aspect is the planet's climatic conditions. Rains of glass and winds reaching speeds of up to 8,000 kilometers per hour create an exotic and extremely hostile world. Recently, thanks to the James Webb Space Telescope, scientists have obtained new data about HD 189733b. The telescope, capable of observing in the infrared range, provided the opportunity to peer into the planet's atmosphere and study its chemical composition. Researchers paid special attention to the search for hydrogen sulfide. Hydrogen sulfide is the primary molecule we were looking for. We suspected it should be in the atmosphere, but we had not yet found it beyond the solar system, says study co-author and astrophysicist Guanwei Fu from Johns Hopkins University. Sulfur is a key element in the formation of complex molecules, and studying it, along with nitrogen, carbon, phosphate, and oxygen, could shed light on the processes of planet formation and their composition. The team of scientists plans to continue searching for sulfur on other exoplanets to understand how a planet's proximity to its star affects the presence of this element in its atmosphere. Another fascinating discovery is the planet known as Super Saturn, uncovered by astronomer Eric Mamajek from the University of Rochester. He identified an unusual planet located 430 light-years away from Earth, whose size far exceeds that of Jupiter and Saturn. However, the most captivating aspect of this discovery is the planet's ring system. Eric stumbled upon this peculiar object while analyzing data from the SuperWASP project. During the study, it was noted that as the planet passed in front of its star, the star's brightness changed in an unusual manner. Instead of the typical decrease in brightness lasting a few hours, the star's brightness diminished over a span of 2 months. Additionally, the brightness fluctuated, increasing and decreasing intermittently. This unusual stellar behavior sparked significant interest among scientists, who, after further analysis, concluded that the object J1407b has an enormous ring system. These super rings are so large that they exceed Saturn's diameter many times over, with a mass of approximately 7.34 10^22 kilograms, comparable to that of the Moon. The radius of the largest ring in this system is estimated at 90 million kilometers, which is about 0.6 astronomical units, whereas the radius of Saturn's largest ring is only about 480,000 kilometers. Interestingly, the star around which this planet orbits is quite young by cosmic standards. At just 16 million years old, it is a mere infant compared to our Sun, which is 4.6 billion years old. Scientists speculate that, over time, the ring system will contract, and the material from it will contribute to the formation of new moons for the planet. Currently, astronomers believe that J1407b might even have a moon the size of Earth. Despite these findings, some scientists remain skeptical, as such a massive ring system has not yet been observed in other stellar systems. Nonetheless, researchers hope that during the next transit of the planet across the star, more detailed data can be obtained. It is possible that the planet's orbit is so extensive that a complete revolution takes 10-15 years. How does Kepler 186 relate to these mysterious observations? Kepler 186f is an exoplanet located in the planetary system of the red dwarf star, Kepler 186, situated in the constellation Cygnus, about 492 light-years from Earth. It is the first planet with a radius close to Earth's found in the habitable zone of another star. The planet was discovered using the Kepler Space Telescope through the transit method, along with 4 other planets orbiting closer to their star. Detecting the signal from Kepler 186f required analyzing data collected over 3 years of observations. The results were first presented at a conference in March 2014, and the official announcement of the discovery was made on April 17, 2014. Kepler 186f completes an orbit around its star in 129.9 days. The star's luminosity is only 4% of the Sun's, making it significantly dimmer. The planet's orbit is at a distance of 0.393 astronomical units from its star, which is close to Mercury's distance from the Sun. The habitable zone of the system covers a range in which the planet receives between 25% and 88% of Earth's illumination. Kepler 186f receives about 32% of the light compared to Earth, making it a prime candidate for potentially habitable worlds. The mass, density and composition of the planet remain unknown. According to various models, the planet's mass could range from 0.32 to 3.77 times that of Earth. If it consists of water and ice, its mass will be closer to the lower end of this range, while if it is predominantly iron, its mass could be nearly 4 times that of Earth. If its composition is similar to that of Earth, its mass would be around 1.44 times that of Earth. American astronomer Elisa Quintana, a scientist in astronomy and planetary science at NASA's Goddard Space Flight Center, notes that the discovery of Kepler 186f is a significant step in the search for potentially habitable worlds. The characteristics of this planet are very similar to those of Earth, but its habitability remains in question. Some scientists suggest that liquid water might exist on the planet's surface, which increases the likelihood of life. If Kepler 186f does have vegetation, its photosynthesis would likely be adapted to the red spectrum radiation from its star. This could lead to a completely different color palette of vegetation, distinct from the familiar green on Earth. Another fascinating planet is J1214b, known as a super-Earth, orbiting the star GJ1214 in the constellation Ophiuchus. It is one of the first exoplanets discovered around a red dwarf. Located approximately 40 light-years from Earth, or about 13 parsecs, it was discovered using the transit method on December 16, 2009, at the Whipple Observatory in the United States. This discovery was a significant step in studying exoplanets, especially those that might be habitable or have Earth-like conditions. The mass of GJ1214b is about 6.55 times that of Earth, but its diameter is 2.5 times larger than Earth's. The planet's density is relatively low, indicating a comparatively low gravity of about 0.91 g, or approximately 8.92 mms2. A year on this exoplanet lasts only 36 hours, with a full orbit around its star taking just 1.5 days. Its close proximity to its star, about 1/7 of an astronomical unit, means that GJ1214b is always tidally locked, showing only one side to the star. The temperature on the planet varies depending on the side. The day side heats up to around 280 degrees Celsius, consistent with theoretical models for a planet with 0 albedo. If the albedo is similar to Venus, the temperature could be around 120 degrees. The night side is much cooler, around 160 degrees. The temperature difference between the two sides is due to the planet being tidally locked, resulting in one half being constantly heated while the other remains in shadow. Recently, the James Webb Space Telescope, JWST, with its MIRI spectrometer, made important observations of GJ1214b, revealing details hidden beneath the planet's cloud cover. Spectral data indicated the presence of water and methane in the atmosphere, as well as heavy elements that astrophysicists refer to as metals. This discovery confirmed earlier hypotheses about the atmosphere's composition and characteristics. Notably, about half of the star's radiation is reflected back into space and does not contribute to heating the atmosphere, supporting the hypothesis of dense clouds covering the planet's surface. Thanks to the JWST, astronomers were able for the first time to conduct a detailed analysis of both the day and night sides of the exoplanet. These data not only expanded knowledge about the planet's thermal balance, but also provided crucial information about its cloud structure. Before such a powerful tool as the James Webb Telescope, such measurements were virtually impossible, making these observations a significant breakthrough in exoplanet studies. GJ1214b is a unique object for research, combining many intriguing characteristics: a super-Earth with low density, tidal locking, and an exotic atmosphere. Observations of this planet help scientists not only better understand the nature of super-Earths, but also draw important conclusions about the composition and structure of their atmospheres. TRES-2b is also an unusual exoplanet that has attracted scientists' attention due to its unique properties. Discovered in 2006 using the transit method as part of the Transatlantic Exoplanet Survey, this planet orbits about 4 million kilometers from its star, GSC 03549-02811, a G0V spectral class star. This distance is significantly smaller compared to the distance between Mercury and the Sun. The proximity to its star makes TRES-2b a gas giant with extreme conditions, including an atmospheric temperature exceeding 980 degrees Celsius. However, the most striking feature of TRES-2b is its remarkable ability to absorb nearly all light that falls on its surface. With a geometric albedo of less than 1%, this planet is the darkest of all known exoplanets to date. It reflects less than 1% of light, making it darker even than coal, soot, or black acrylic paint. There are no planets or moons in our solar system that can match TRES-2b in terms of light absorption. In comparison, Earth reflects about 36% of light, while Jupiter reflects about 50%. The reasons for TRES-2b's extraordinary darkness are believed to be related to its chemical composition and the processes occurring on its surface. It is possible that unique chemical reactions are taking place on this planet, which scientists have not yet observed elsewhere in the universe. Astronomers speculate that the planet's atmosphere might consist of substances that contribute to its ability to absorb nearly all light. Despite the extreme temperatures, these unknown compounds allow TRES-2b to remain almost invisible when light strikes it. TRES-2b can be compared to a black hole in terms of its light-absorbing capabilities, though it obviously does not possess the gravitational characteristics of a black hole. Scientists continue to study this fascinating celestial body, hoping to uncover the mysteries of its chemical composition and the processes occurring on the planet. What secrets does the exoplanet WASP-76b hold, and will it surprise us as much as TRES-2b has? The exoplanet WASP-76b is an intriguing object classified as a hot Jupiter, located in the constellation Pisces. WASP-76b orbits its star at a distance of just 0.033 AU, which is approximately 4.9 million kilometers. This object is notable for its rapid orbital period, only 1.8 days. The planet's mass is comparable to Jupiter's, about 92% of its mass. The temperature on the planet's day side is extreme, around 2500 K, approximately 2227 degrees Celsius, making this exoplanet particularly interesting for studying atmospheric processes. Data collected using space telescopes such as Hubble and Spitzer indicate the presence of elements like titanium oxide and small amounts of water in the planet's atmosphere. Additionally, spectral studies have revealed the presence of various ionized elements, including lithium, sodium, magnesium, calcium, manganese, and iron. Observations from the Northern Gemini Observatory in 2021 confirmed the presence of calcium, while barium was detected in 2022. Thus, the chemical composition of WASP-76b's atmosphere represents a unique example of the complex interaction of elements under extreme conditions. The planet's atmosphere has been described as cloudy, with a predominant gray color. Significant thermal heating is observed, which in turn generates the high temperatures needed for the evaporation and condensation of neutral iron. In March 2020, scientists detected neutral iron in the atmosphere of WASP-76b, hypothesizing that at temperatures around 2400 degrees Celsius, this iron could evaporate and then condense as liquid rain at around 1400 degrees Celsius. This led to the hypothesis of an iron rain, though subsequent data have cast doubt on this phenomenon. In May 2020, a new study based on Hubble observations showed that early spectra were distorted by light from a companion star. This required a revision of the atmospheric model, which now suggests a hydrogen-helium envelope with previously observed signs of neutral iron excluded. Questions about the existence of iron condensation on the planet remain unresolved, and further observations are needed to fully understand the occurring processes. Models of atmospheric circulation suggest that clouds on the planet may form from aluminum oxide, neutral iron, or magnesium orthosilicate. However, data do not indicate significant amounts of condensed iron on the planet's night side. which further complicates the understanding of its atmospheric processes. An interesting discovery was made in 2022, when scientists using the Cheops telescope detected signs of an optical phenomenon known as a glory in the atmosphere of WASP 76b. A glory is an optical phenomenon resulting from the diffraction of light returning in the same direction after reflection from particles in clouds. This phenomenon had previously only been observed in the atmospheres of Earth and Venus, and its possible detection on WASP 76b is of great interest. If the glory discovery is confirmed, it could provide valuable information about the composition of the planet's upper atmosphere and indicate stable temperature conditions in its clouds. What secrets might Gliese 581c reveal if the discovery of glory on WASP 76b already sparks such interest? Gliese 581c is an exoplanet in the planetary system of the star, Gliese 581, located approximately 20 light-years from Earth in the constellation Libra. The exoplanet was discovered in April 2007 by a team of scientists from the European Southern Observatory, ESO, working at the La Silla Observatory in Chile. The discovery was made using a 3.6-meter spectrograph telescope, which allowed for the detection of the planet by observing the star's light variations at different wavelengths through the method of Doppler shift. Gliese 581c is noteworthy not only as one of the first exoplanets found in the habitable zone of its star, the region where conditions might allow for liquid water to exist, but also for its proximity to the star. The planet orbits Gliese 581 in just 13 Earth days, with a distance of about 11 million kilometers from the star. In comparison, Earth is approximately 150 million kilometers from the Sun. These characteristics make the planet particularly interesting to astronomers studying the potential for life on exoplanets. Gliese 581c has made an impact not only in science, but also in popular culture. In 2007, Estonian singer Laura Poldvere released a song titled 581c, inspired by the exoplanet. The track was featured on her album Muusa and won the Radio Hit of the Year award at the annual Estonian Pop Music Awards in 2009. This example illustrates how astronomical discoveries can influence not only scientific communities, but also the arts, leaving a mark on the culture of various countries. How do the features of the exoplanet 55 Cancri E open new horizons in astronomy? The exoplanet 55 Cancri E, also known as Janssen, is a unique world located approximately 40 light-years from Earth. Discovered using the Hubble telescope, it immediately attracted scientists' attention due to its extreme characteristics. This planet falls into the super-Earth category, meaning it is rocky and significantly larger than our planet. Its mass is about 8 times that of Earth, and its diameter is twice as large. What makes 55 Cancri E particularly interesting is its incredible conditions. The planet orbits very close to its star, an orange dwarf named Copernicus, which is slightly smaller than our Sun. As a result, a year on 55 Cancri E lasts only 17.5 hours, and surface temperatures reach up to 1982 degrees Celsius. The planet's surface is likely a vast ocean of magma heated to extreme temperatures. These conditions make the planet resemble a hellish world with unbearable heat and constant molten rock activity. Despite such extreme conditions, scientists speculate that real treasures may lie deep within the planet. Researchers believe that 55 Cancri E may contain significant reserves of diamonds, making it even more intriguing for further study. The exoplanet HR 5183b, located in the constellation Virgo at a distance of 102 light-years from Earth, is one of the most unusual discoveries in astronomy. It was discovered in 2019 using the radial velocity method, which measures the impact of a planet on the motion of its star. HR 5183b is a gas giant with a mass 3.24 times that of Jupiter. One of the main features of HR 5183b is its extremely elongated orbit, which sets it apart from other exoplanets. The orbit's extreme eccentricity is 0.84, causing the planet to vary in distance from its star between 2.88 astronomical units and 33.1 AU. For comparison, If its trajectory were superimposed on our solar system, its perihelion would lie inside the asteroid belt, while its aphelion would be far beyond Neptune's orbit. The planet takes 77 years to complete one orbit around its star HR 5183. HR 5183b is unlike any planet in our solar system, and as researcher Sarah Blunt notes, it also differs from most exoplanets discovered so far. Other planets detected far from their stars generally have very low eccentricities, meaning their orbits are more circular. The high eccentricity of this planet suggests some differences in how it formed or evolved, Blunt emphasizes. So how did HR 5183b end up on such an unusual orbit? According to scientists, it likely experienced a strong gravitational influence from another large celestial object. It is hypothesized that HR 5183b may have had a neighboring planet of similar size in the past. When these planets came too close to each other, one was ejected from the system, resulting in the highly elongated orbit of HR 5183b. Each of the described planets represents a unique and thrilling field of research, highlighting the diversity and extreme conditions encountered in our universe. These planets offer us entirely new perspectives for exploration. Each of these discoveries not only expands our understanding of possible conditions for life, but also challenges our grasp of the dynamics and evolution of planetary systems. These exotic worlds open new horizons for scientists, allowing them to better understand how planets form and evolve, as well as how they interact with their stars. Don't miss the opportunity to keep up with the latest astronomical discoveries and news by subscribing to our channel.